black hole the most terrifying thing we know, a place where light dies, time freezes, and even reality loses its shape. We fear it because it swallows everything. But what if it already swallowed us? What if Earth, the stars, the galaxies, our entire universe exist inside one? Scientists say black holes compress everything inward, yet our universe expands outward. That contradiction haunts cosmology. Could the Big Bang have been not a beginning, but a collapse from another world? If that's true, then every sunrise, every planet, every stars, every distant galaxy is unfolding inside a cosmic abyss. Now we'll dive into how the universe was born, how it might die, and whether everything we know is already happening inside the very thing we thought only destroys. You lie beneath a quiet sky, and for a moment the world below disappears. Above you, the darkness isn't empty, it breathes. Tiny points of light scatter across a vast canvas, some close, most impossibly far. Each star is a messenger, its light leaving home millions, sometimes billions of years ago, now arriving softly to touch your eyes. You're not just looking at the night, you're looking through time itself. Astronomers call this the observable universe, everything, whose light has had enough time to reach us since the beginning, nearly 13.8 billion years. Beyond that horizon, light is still traveling forever unseen. The distance is so great that what you see tonight may no longer exist. Some stars have already died, some galaxies have merged and vanished, yet their light continues on, carrying memories across oceans of space. Imagine standing at the edge of that visibility. Beyond it, darkness reigns, not the absence of light, but a silence too deep for photons to cross. Scientists know this boundary is not physical, but temporal, a wall made of time itself. If you could journey faster than light, you might pierce it, but every theory insists you cannot. The cosmos hides its farthest truths behind this perfect limit, and still your eyes keep searching. Why does this darkness feel familiar? Perhaps because it holds everything that made you, atoms forged in dead stars, energy born from the first fire of creation. You're in every sense made of starlight looking back at its origin. Now imagine that this vastness is not infinite, but enclosed like the interior of a cosmic sphere. Suppose all of space curves inward upon itself, its light bending its edges, folding into a secret center. Could it be that when you gaze outward, you're also looking deeper within? If so, then every star, every breath, every heartbeat may echo inside something larger, something that holds the universe the way gravity holds light. As you breathe in, the stars shimmer faintly. Their light travels across unimaginable distances to find you here in this small corner of space and time. You close your eyes, and the night continues its silent expansion. Somewhere beyond what any telescope can see, the question begins to whisper, what if all of this lies inside something else? When you open your eyes to the night again, the stars no longer feel infinite, they feel measured. Science, after all, is our lantern in the dark. Yet even the brightest lantern can only cast its glow so far. Astronomers have stretched that glow across unimaginable distances. Using telescopes like Hubble and James Webb, they've mapped galaxies billions of light years away, tracing the faint whispers of radiation from the universe's first moments. They call that afterglow the cosmic microwave background, a ghostly heat left from the Big Bang filling all directions equally. To human eyes it would be invisible, but to sensitive instruments it looks like a fog of light, soft and ancient, wrapping the entire sky. That fog marks the edge of what we can ever observe. Beyond it, no signal can reach us. The light from farther realms hasn't had time to arrive. This limit isn't drawn by walls or gravity, but by time itself. The cosmos has existed for 8 billion years, light simply hasn't had longer to travel. The number sounds vast, but in cosmic proportion it's the blink of an eye. Imagine standing on a beach at night. The sea before you stretches endlessly black and silent, but your flashlight pierces only a few meters into the waves. Everything beyond that cone of light remains hidden, though you can sense it there, the movement, the depth, the unseen creatures gliding through the dark. That is how astronomy works, a small cone of knowledge shining into an ocean of mystery. Through that narrow cone, scientists have uncovered exquisite detail. They can measure the rotation of distant galaxies, the chemistry of exoplanets, even the wobble of invisible black holes. Yet every discovery draws the same conclusion: there is more we cannot see than what we can. The observable universe with its 2 trillion galaxies may be only a droplet in an unseen sea. To test these limits, physicists turn to mathematics, bending space and time with equations that predict what eyes will never witness. According to general relativity, space itself can curve. Look far enough, and you may end up where you started, as if the universe wraps around on itself. Others imagine it stretching endlessly unbounded, its edges receding faster than light. Both pictures fit the data. Both defy intuition. And so science stands at its frontier, a place where observation fades into inference, where facts lean toward faith. Yet this faith is not blind. It is built on the reliability of light, on the predictable dance of gravity and atoms. Still, somewhere past the last measurable photon, the human mind begins to wonder. If every telescope shows us only a fraction of reality, what lies beyond the reach of its mirrors, is there more universe out there, or another kind of existence entirely? Perhaps the question itself is the next experiment, not to see farther, but to understand what seeing truly means. You breathe again, slowly. The night feels larger now, not because it has grown, but because you've realized how little of it is known. The sky above is no longer an answer, it's an invitation. Every great question begins with a simple act of imagination. Tonight that act begins here, beneath a sky that has seen everything but reveals almost nothing. We know the universe expands. We know its galaxies drift apart as space itself stretches. Yet hidden inside that expansion lies a contradiction too elegant to ignore. What if this outward motion is not the universe escaping into nothingness, but unfolding within something else physicists have long studied, the strange relationship between gravity and creation? Gravity pulls, bends, compresses. Expansion pushes, cools, and separates. They seem opposite, yet they may be two sides of the same law. Inside a black hole, gravity grows so intense that space and time trade roles. Time becomes distance. Distance becomes time. Matter falls inward forever, never to return. But what if that collapse is not an end? What if on the other side of that gravitational veil, an entirely new universe blossoms outward? The equations allow it. How? Einstein's general relativity does not forbid such a bridge. Some call it an Einstein-Rosen tunnel. Others a white hole where all the matter that fell in somewhere else bursts outward again. If true, every black hole could be a seed, a cosmic womb giving birth to new universes. And if that is so, ours may be the offspring of another older reality. Imagine it, everything you see, every galaxy, every atom in your body, once compressed inside the event horizon of a parent black hole. What we perceive as the Big Bang might have been the moment that collapse turned inside out. Our universe then would not have exploded into nothing. It would have expanded into its own private space, nested within a larger one. It sounds impossible, and yet the numbers whisper agreement. The size of our observable universe nearly matches the radius that a black hole of equivalent mass would have. The symmetry is haunting. If this is true, the night sky above you is not empty. It is the inner wall of a grander structure, the boundary of an ancient collapse. Somewhere beyond that invisible horizon lies a place we can never reach, because it is not our universe at all. You breathe out slowly. The thought doesn't frighten you, it humbles you. Perhaps existence itself is recursive, every universe born from another, each carrying the memory of its parents' fall. The night around you lingers soft, immense, alive with silence. The thought from before still echoes in your mind. What if everything we know is happening inside something larger? That question doesn't fade, it deepens. Slowly, like gravity itself, it draws you inward. To follow it, we must return to the very beginning, to the first instant, the first breath of existence. Long before galaxies spun or stars were born, before atoms and light, everything that would ever exist was condensed into something smaller than a grain of sand. Physicists call it a singularity, a point where the known laws of space and time collapse. The density and temperature rise beyond all meaning. Gravity no longer curves space, it consumes it. And then something changed. Roughly 13.8 billion years ago, that singularity didn't stay still. It expanded. In less than a heartbeat, it inflated faster than light stretching energy, and matter outward cooling as it grew. That is the moment we call the Big Bang, not an explosion in space, but the birth of space itself. There was no outside for it to explode, into no edge to cross. Everything expanded everywhere all at once. Imagine standing within that first fraction of a second. The universe would be blinding opaque, filled with a plasma so hot that atoms couldn't exist. Light couldn't travel freely. It scattered endlessly, trapped in the glow. As the universe cooled, protons and electrons combined and light was finally released. That ancient light still surrounds us. It's the cosmic microwave background, a faint whisper of the first dawn. In that radiance, galaxies began to take shape. Clouds of hydrogen condensed under gravity, spinning, clumping, igniting. The first stars burst alive like sparks on a cosmic tide. Every element you know, carbon, oxygen, iron, was forged inside those early furnaces. When those stars died, they scattered their riches, seeding the dark with potential. The universe was no longer a singular fireball. It had become a sea of stars. But the symmetry remains haunting. The Big Bang, a moment of release. A black hole, a moment of collapse. One expands, the other implodes. And yet when physicists compare the two, they find equations that mirror each other almost perfectly. The singularity at the heart of a black hole behaves in many ways like the singularity that birthed our cosmos. Could the Big Bang have been the inside of a black hole's heart? The idea doesn't just sound poetic, it's mathematically possible. Inside a black hole, time points inward. But if the collapse continues, there might be a threshold, a bounce where the inward flow reverses. To an observer beyond, it remains forever hidden. To us inside, it could appear as expansion. In that sense, the Big Bang and a black hole might be two perspectives of the same event seen from opposite sides of reality's mirror. If that were true, then every point of light above you, the stars, the galaxies, the nebulae, are not escaping into emptiness. They are part of a vast unfolding inside the shadow of something greater. The sea of stars we float through may be the inner glow of a cosmic womb. You close your eyes for a moment and the scale overwhelms you. From a singularity smaller than imagination to a sky that stretches beyond sight, existence itself has been expanding for nearly 14 billion years, and still it grows. Somewhere beyond the veil of known physics, gravity whispers the same story it began with collapse, creation, and the endless dance between them. The story continues because even in the sea of stars, the pull of the singularity remains. It waits patient and hidden in the heart of every galaxy, reminding us that the beginning and the end may in truth be the same. The thought lingers as the music of the cosmos drifts on. If the universe was born from a singularity, could that same force still live within it? The question trails from the sea of stars you've just traveled through, a current pulling you deeper into the heart of creation. Gravity. The most familiar, the most mysterious. You feel it even now, holding you to Earth, shaping the ocean's tides, guiding the moon in its orbit. Yet in truth, gravity is not a force in the ordinary sense. It is the geometry of existence itself. Einstein revealed this in 1915. Space and time are not a backdrop, but a fabric one that bends and curves in the presence of mass. Every star, every planet, even your body dimples the cosmic surface just a little. The universe doesn't simply exist within gravity. Gravity is the universe's shape. From the first fraction of a second after the Big Bang, gravity was the sculptor. It gathered loose hydrogen into clouds, clouds into stars, and stars into galaxies. It wove the large-scale structure of the cosmos, the filaments, the clusters, the dark voids in between. In its gentlest form, it gives rise to orbits, balance, rhythm. But its nature is dual, patient and nurturing, yet relentless and hungry. Because gravity never stops. It always pulls, always gathers, and in the end it devours what it creates. A star born from gravity's embrace will one day exhaust its fuel, lose its inner pressure, and collapse back under its own weight. If massive enough that collapse will not stop, not even light can escape. The maker becomes the destroyer. What once shaped the cosmos begins to consume it. Imagine one of those dying giants 30 times the mass of our sun imploding in on itself. Space folds, time stretches, and matter disappears beyond an invisible threshold, the event horizon. To an outside observer, the fall seems eternal, slowed by time dilation. But from the star's own perspective, the end comes swiftly. Inside, everything compresses toward a point smaller than an atom, a singularity of infinite density. The same kind of singularity, perhaps, that once gave us birth. This symmetry haunts every physicist who studies the sky. Why does the universe that began with expansion contain within it countless objects built to collapse? Why would the same physical laws write two opposing fates into the same script? Some theories suggest it is inevitable. The cosmos must balance creation and destruction. Energy must cycle, not vanish. The Big Bang spread matter outward, and gravity began the long work of drawing it back in. Every black hole could be a small rehearsal of that grand return, a pocket of space performing the same act that began everything. Others imagine a deeper elegance. Perhaps gravity is not the universe's enemy, but its memory. Each collapse a reminder of where it came from. Each black hole a portal back toward the origin. In this view, the universe is self-sustaining, feeding on its own echoes. Nothing wasted, nothing lost. You look up again. The stars, the galaxies, the very shape of the night, each is a testament to gravity's artistry. But in every masterpiece lies a trace of destruction, the shadow that completes the light. From the singularity that gave birth to the stars to the black holes waiting to reclaim them, gravity holds the cosmos in its paradoxical embrace. It is the hand that molds and the mouth that swallows. The universe breathes in expansion and exhales in collapse, and somewhere in that endless rhythm, creation and consumption become one and the same. The night remains vast, and your thoughts still circle the paradox of gravity, how it builds and devours, how every act of creation hides the seed of collapse. If gravity can both give birth and destroy, then perhaps these two moments, Big Bang and black hole, are not opposites at all. Maybe they are two halves of the same breath. From that idea, a daring hypothesis emerges. What if our universe was born inside a black hole? At first, it sounds absurd. A black hole, after all, is where light itself vanishes, where time slows to nothing. Yet the mathematics of general relativity whisper something stranger. According to Einstein's equations, the interior of a black hole doesn't simply end, it transforms. Beyond the event horizon, space and time trade roles. What we think of as falling in may, from another perspective, be expanding out. Picture a collapsing star. Its core implodes, crossing the event horizon, crushed into a singularity. From the outside, everything freezes at that edge, trapped in time, but inside the geometry changes. To an observer who could somehow survive the passage, time would flow forward into a new dimension. Space itself could expand within. It would feel in every measurable way like a new universe being born. Physicists call this idea the black hole cosmology hypothesis. It proposes that every black hole may contain its own baby universe, its own enclosed bubble of space-time detached from the parent. In that case, the Big Bang wasn't a singular explosion into emptiness. It was the blossoming of an interior world. The black hole that birthed us would exist in another larger cosmos, our parent universe. There's even a haunting numerical hint. If you take the mass of our observable universe and calculate the radius of a black hole with the same mass, the numbers nearly match, about 46 billion light-years. It's as though the universe we can see fits perfectly inside the boundaries of its own event horizon. Coincidence or cosmic clue? If that symmetry holds, then the night sky above you isn't infinite space. It's the inner wall of a gravitational cocoon. Every photon, every galaxy, every beam of light is trapped, swirling within this immense curvature. The reason we cannot see beyond the observable edge may not only be the limit of light's travel, it may be that beyond that edge lies another reality altogether, one we can never reach because it is outside the very fabric of our universe. Imagine that moment of transition, the instant when the parent universe's collapsing core crossed its own threshold. From the outside, it was a death matter disappearing into darkness. From the inside, it was a beginning, a burst of expansion, a big bang. To the parent, it was the closing of a black hole. To us, the opening of a sky. And perhaps this pattern repeats endlessly. Every black hole gives rise to a new universe. Every universe in time forms black holes of its own, continuing the chain. A cosmos within a cosmos, nested without end, each generation carrying the constants and laws inherited from its ancestor. Our gravity, our physics, even our time could be genetic traits passed down through cosmic lineage. You inhale slowly. Somewhere far beyond imagination, a black hole in another universe may still hold the memory of our birth. And one day, within one of our own black holes, another reality may bloom its inhabitants, looking up at their night sky, wondering as we do now what lies beyond their horizon. The last echoes of the previous thoughts still drift through the vastness, the idea that our universe might have bloomed inside a black hole, that the collapse of one world became the birth of another. You let that thought settle like starlight fading through deep water. And now you find yourself moving backward again, toward the moment before. Imagine standing on the edge of time, if standing even means anything. There is no sound, no distance, no direction. Space has not yet unfolded and time has not begun to flow. The universe exists only as potential compressed silent waiting. Then, in less than a fraction of a heartbeat, it ignites. Reality itself opens its eyes. Physicists call this instant the Planck era, a time so short it defies human comprehension, 10 to the power of minus 43 seconds. Temperature 100 million trillion degrees. Energy so dense that the very concept of matter breaks apart. At that scale, the four fundamental forces, gravity, electromagnetism, the strong and weak nuclear forces, were not separate yet. They were one unified pulse vibrating in a sea of raw existence. Now imagine that you are there not as a body but as awareness suspended in brightness so pure it burns thought itself. Time does not pass, it appears. Each fluctuation, each quantum tremor in that blazing field is the first tick of a cosmic clock. From these tremors, space-time begins to ripple outward like rings on a pond, and gravity, the quiet architect of everything, takes its first breath. If you could somehow measure this birth, you would find that distances are meaningless a centimeter, then could stretch to the size of a galaxy in less than a blink. And yet even in this chaos there is symmetry. Tiny differences in energy density, 1 part in 100,000, became the seeds of all structure that would follow. Picture it a universe less than a trillionth of a second old, but already expanding faster than light. It isn't an explosion, it's the fabric of reality stretching, doubling, tripling 100 times over in an instant. Physicists call this cosmic inflation, and it smoothed the wrinkles of creation, turning a quantum foam into the flat, vast cosmos we see today. Now take a breath. You're inside that moment, riding the wave of space as it unfurls. Each breath you draw now, billions of years later, is made of particles born in that furnace. The hydrogen in your blood, the photons that warm your skin, they are ancient travelers from that first dawn. To grasp the scale, imagine this. If the entire age of the universe were compressed into 1 year, the Planck era would last less than a blink at midnight on January 1st. And yet without that blink, nothing else could follow. From the smallest vibration came galaxies, stars, and the ground beneath your feet. It's possible, some theorists say, that what we call the beginning was not unique. Perhaps time has been born countless times, each black hole in each universe giving birth to new time inside. If so, then every singularity carries a heartbeat, a rhythm of creation echoing through dimensions beyond our reach. You close your eyes. In the darkness behind your eyelids, you can almost feel that rhythm, a low, endless hum beneath the silence. It is the sound of gravity discovering itself, the first curve in space, the first direction of time. And as that hum deepens, the brightness cools. The universe expands and the energy begins to gather into tiny pockets, the seeds of matter, the first shadows of form. Somewhere within those newborn ripples hidden in the light lie the earliest black holes, infinitesimal, dense, the first memories of gravity folding in on itself. They will become the architects of galaxies and perhaps the ancestors of the very black hole that birthed us. The brightness fades and from its glow emerges the faint pulse of time. Moments begin to separate from one another, still immeasurably brief but distinct enough to count. You drift forward from the birth of time itself through that first second where the energy of creation starts to settle into pattern. The story that began as pure light now begins to take form. In the cooling ocean of radiation, fluctuations stir tiny variations in density, born from the quantum tremors of the Planck era. They are almost nothing, 1 part in 100,000, and yet these differences will decide the fate of everything. Where energy gathers just a little more tightly, gravity begins to whisper. Where it gathers again, it sings. Imagine watching that ocean from above as if you were a traveler floating above an endless field of glowing mist. In some places the mist shimmers slightly brighter, its fabric folding inward under invisible weight. Those folds, those dimples in the newborn universe are the first gravitational seeds. From them everything we know will one day bloom. Physicists call these density perturbations. They are the fingerprints of quantum fluctuations magnified by cosmic inflation into structures large enough to shape galaxies billions of years later. Gravity found them irresistible. Over cosmic time, these regions would attract more matter, their pull growing stronger, their mass collapsing tighter. Some of them would stop as stars, some as galaxies, and some would go further, falling into themselves completely. In the earliest instance after inflation, when the universe was still less than a heartbeat old, a few of these dense patches may have crossed a hidden line. Their own gravity overpowered the expansion around them, forcing them to collapse, even as the rest of space kept stretching. In those fleeting instants, black holes were born, tiny, ancient, and unimaginably dense. Physicists call them primordial black holes. To understand their scale, imagine one with the mass of a mountain compressed into something smaller than a grain of sand. or another as heavy as the moon, yet invisible, hiding within a space smaller than the head of a pin. If such objects still wander through our galaxy today, they would be silent ghosts passing through planets, through stars, even through you, without leaving a trace. These primordial black holes could have formed in enormous numbers, their population determined by the delicate balance between the universe's expansion and the clumping of its earliest matter. Most may have evaporated long ago, dissolved by Hawking radiation, the slow quantum leaking of mass from a black hole's horizon. But some might have survived drifting unseen, carrying within them the record of the universe's first heartbeat. Now imagine zooming in on one of those seeds. At first it is only a vibration, an overdense patch of plasma glowing brighter than 1,000 suns. Then gravity tightens its grip. The light bends the space curves and suddenly there is no outside left. A horizon forms, marking a boundary that even photons cannot cross. In that instant, a black hole appears, a newborn shadow in the light of the first dawn. It is strange to think that these ancient singularities might be far older than any star or galaxy, that they were witnesses to the universe's infancy. Perhaps they are still out there, scattered through the cosmic dark, too small to see yet holding clues to the riddle of our own beginning. Some cosmologists even whisper a possibility one of them could have grown large enough, fed by time matter, and chanced to become the mother of all galaxies, or even the womb of our universe itself. You float now among those invisible seeds, hearing the faint murmur of gravity as it shapes the young cosmos. Light moves freely for the first time, but shadows already exist, the first paradox, the first sign of what's to come. The light of the early universe fades into a quieter glow. You drift through a sea of invisible points, each one a memory of collapse, each one a bubble in the expanding fabric of space. Behind you, time has stretched from the first second to minutes, and the chaos of creation has softened into rhythm. Gravity hums beneath everything now, a quiet pulse keeping the universe together. Those primordial black holes, tiny and ancient, still drift unseen. Each one is a pocket of space-time cut off from its surroundings, a region where the rules of reality fold in on themselves. From the outside, they appear as voids. From the inside, who can say, if the equations of general relativity hold, then every black hole could hide an interior universe, a complete cosmos with its own space, its own time, its own laws. Imagine that each of those bubbles expanded inward, creating entire worlds within worlds. Some may have collapsed quickly, fading without trace. Others might have lasted long enough for galaxies to form, for light to travel, for beings to look up at their own night skies, wondering as you do now what lies beyond their horizon. What if ours is one of them? What if the very stars you see are floating inside the curved walls of a cosmic bubble, born from another universe's collapse? In that vision, the Big Bang wasn't the beginning of everything. It was a continuation, a transformation. The death of one world gave birth to ours. We are the offspring of a previous reality, carrying within us the physics, the constants, and perhaps even the echoes of that forgotten parent. Close your eyes for a moment. Picture the edge of our observable universe, a distant curtain of light, soft and unreachable. Now imagine that curtain as the inner wall of a vast bubble, a horizon we can never pass, because it defines the space we live in. Beyond it lies not more stars, but another dimension, a deeper layer of existence. If that is true, then the universe is not infinite. It is recursive, an endless nesting of realities, each born inside the collapse of the last. And here you are inside one of them, breathing, thinking, made of starlight that remembers a previous sky. The thought drifts with you from before the possibility that we might be living inside one of those ancient bubbles, a universe curled within another. You breathe slowly and open your eyes. The blackness around you is no longer empty. It's alive, trembling with a faint golden shimmer. For a long time the cosmos was dark. The first stars had not yet been born, and light, though present, was trapped, bouncing endlessly among particles too dense to let it go free. The universe, still a child, glowed not with starlight but with heat, a fog of radiation that wrapped every corner of space in uniform warmth. Now imagine you're standing inside that fog billions of years ago. The air, if we can even call it that, is not air at all, but plasma, electrons and protons moving so fast that they cannot bond. Every direction looks the same, a radiant sea of brightness. Then slowly the temperature falls, space stretches, particles drift apart, the universe takes a breath. At around 380,000 years after the Big Bang light is finally set free, electrons join with protons to form atoms, and suddenly space becomes transparent. The photons, no longer scattered, begin their long journey outward. They have been traveling ever since, across time, across galaxies, across the entire age of everything. And some of them are reaching you right now. Look up. The night sky, you see the faint shimmer between the stars, still carries that ancient light. Scientists call it the cosmic microwave background, or CMB. It's the oldest light we can detect, the afterglow of creation itself. It bathes the entire sky equally faint and cool, just 3 degrees above absolute zero. If your eyes could see microwaves, the sky wouldn't be black. It would glow softly, evenly, like warm breath on cold glass. Every point in that glow is a message from 13.8 billion years ago, a whisper from the universe when it was only a child. Now imagine holding a mirror up to the edge of the cosmos, a telescope so powerful it can look backward in time. In 2021, humanity built one. Its name is the James Webb Space Telescope. You can picture it: gold hexagonal mirrors unfurling in the dark, suspended at the L2.1.5 million kilometers from Earth. Each mirror segment as wide as a person, the whole structure gleaming like a mechanical flower. It faces away from the sun, its golden eye open to the deep. James Webb is not just a telescope, it's a time machine. Its instruments detect infrared light, the stretched, faded glow of the universe's earliest stars and galaxies. The farther it looks, the older the light it receives. When it stares into the abyss, it sees moments less than a few 100 million years after the Big Bang. Imagine you're there beside it, floating quietly the Earth, now a tiny blue ember far behind. The telescope turns toward a patch of sky that looks empty to your eyes, but as it focuses, faint galaxies bloom out of the darkness, red, stretched, ancient. Each one smaller than a pixel in the night, yet vast enough to hold hundreds of billions of stars. You watch the first dawns of creation unfold before you. Galaxies forming from collapsing clouds of hydrogen stars, igniting one after another like sparks across a cosmic ocean. You see light where there had been only darkness. That light is old, beyond comprehension. The photons captured by Webb left their sources 13.5 billion years ago. In that time, entire galaxies have been born and died. Stars have risen and fallen, and through it all, those same photons have traveled straight, silent, patient, until now, when they meet the telescope's mirror and awaken once more as data. Scientists on Earth call it first light. But in truth, it is the oldest light we will ever see. Think about what that means. The light Webb captures isn't just ancient, it's finite. Beyond a certain distance, even light cannot reach us. We are looking at the farthest edge of what is visible, the inner wall of our bubble universe. Now picture this. The telescope is gathering light that has been stretched by the expansion of space itself. Wavelengths that began as ultraviolet are now red, then infrared, stretched 1,000-fold. It's as if time itself has pulled them thin. When the telescope collects them, it isn't just seeing across space, it's seeing across the history of everything. And here comes the haunting thought. What if that outermost light isn't only the boundary of visibility, but the very skin of the black hole that contains us? What if the horizon we see in cosmic light is also the event horizon from which our universe cannot escape? You feel it, that subtle shiver in the vastness. You standing here beneath the same night sky are seeing the same light that left its source before Earth existed. The same light that journeyed across the curvature of space-time, passing through cosmic storms, supernovae and dark voids. Every photon that touches you is older than your world. Take a slow breath. Let it sink in. The night above is not a ceiling, it's a message. Every point of light is a story of survival, a letter from the dawn of everything finally arriving after 13.8 billion years for you to see. That ancient light still glows softly behind your eyelids. The memory of the James Webb's golden mirror lingers, a vast mechanical eye capturing the oldest light in existence. You're still there, floating beside it, suspended between stars as the telescope continues to peer into the deep. And then, something unexpected begins to appear. The data streams back to Earth, numbers, colors, spectral lines, and from those numbers, images emerge, delicate spirals, glowing filaments, galaxies so young they should not exist yet according to our models. But that's not the strangest part. There is a pattern, faint but persistent. Astronomers notice it first in passing as they count the galaxies in one region of the sky. Nearly 2/3 of them seem to twist clockwise while the rest spin in the opposite direction. It shouldn't be possible. According to the cosmological principle, the universe should look the same in every direction, no preference, no bias, no cosmic handedness. Everything on the larger scale should be random isotropic evenly spread. But this is different. Imagine you're looking down from above at a field of whirlpools. Each galaxy is one vortex, billions of stars swirling in a spiral dance. If the cosmos were truly uniform, half of those whirlpools should spin one way, half the other. Instead, in this vast patch of sky, the whirlpools all seem to lean to one side as if the universe itself were rotating. The James Webb data deepens the mystery. More regions show the same imbalance. Patterns of spin repeat across immense distances as though the fabric of space-time remembers a direction. Could it be a coincidence, a sampling bias? Maybe the instruments caught a quirk of observation. Scientists double-check, recalibrate, and cross-compare. Still, the asymmetry remains. You float there beside the telescope again, and the thought comes quietly. What if the universe isn't as symmetrical as we believed? What if this cosmic tilt isn't random at all? Some theorists begin to whisper about the unthinkable. They recall the equation that links spin mass and curvature. Every rotating black hole, a Kerr black hole, drags space-time around with it, a phenomenon called frame dragging. Inside such a black hole, space doesn't just curve, it twists. And if our universe exists inside one of those, if the black hole that birthed us was spinning, then every galaxy, every atom might still carry that rotation. The spiral arms of galaxies, the preferred direction of cosmic structures, even the subtle alignment of light polarization, all could be the fingerprints of that original spin. You take a breath imagining the scale of such motion. If the entire cosmos is rotating, its axis would stretch across billions of light years. Every sunrise, every orbit, every pulse of your heart would be part of that same grand rotation, so slow, so vast that no single observer could ever feel it. It's dizzying to think about a universe whirling inside a larger one, space itself, twisting like the surface of a whirlpool. Perhaps the galaxies aren't simply drifting away from one another, perhaps they're caught in a greater spiral, following the rotation of the black hole that contains us. Still, astronomers are cautious. No conclusion, no claim of certainty. But the numbers persist and the symmetry refuses to return. If true, this would challenge one of the most sacred assumptions of cosmology, that there is no preferred direction, no up or down, no cosmic bias. It would mean the universe has an orientation, a spin, an origin, a memory. You look again at the spirals blooming on the telescope screen. Each one seems to whisper a secret motion, a trace of the deep past. And suddenly you remember the thought from before, the idea that we live inside a black hole, that everything we see is the interior of a collapse. If that were true, then this rotation is not a flaw in our data. It's a clue. It's the shadow of our origin. You close your eyes and imagine it, a single rotation echoed across all of existence. Galaxies turning stars, spinning atoms, dancing in their orbitals, planets, revolving in ancient rhythm, each motion part of the same hidden song. It is gravity's oldest refrain, the memory of the first twist that birthed the cosmos. A rotation so immense that it shapes the structure of reality itself. You are part of that turning. Every breath, every heartbeat, a continuation of the spin that began when time was young. The universe continues to turn in your mind, a vast spiral inside an even greater silence. The golden light of James Webb fades, and you drift further outward beyond the galaxies that twist in unison toward the faint, unreachable edge of sight itself. The last thought still echoes: if the cosmos truly carries a rotation, if we are living inside a spinning black hole, then there must be a boundary, a place where motion ends and mystery begins. You look up. Before you stretches the farthest thing that can ever be seen, a faint wall of light, smooth, and even the cosmic horizon. It is not a physical edge, not a wall you could touch or cross. It's the limit of what light has had time to reach us since the beginning. Beyond it, time itself has moved faster than photons can travel. That invisible shell is where visibility ends and speculation begins. But there's another way to think about it. What if this horizon is not just a limit of distance, but a limit of existence? What if it is the inner surface of something much greater, the boundary of the black hole that birthed us? Imagine standing on Earth and pointing outward toward the most distant galaxy. That faint red smudge of light, stretched by 13.8 billion years of expansion, marks the edge of the observable universe. If you could somehow measure the mass contained inside that vast sphere, every star, planet, particle, photon, and whisper of dark matter, you would find a number so immense that its own gravity would form a black hole of cosmic size. Physicists have done this calculation. The radius of that hypothetical black hole, its Schwarzschild radius, matches almost perfectly the radius of our observable universe. The symmetry is eerie, almost poetic. It's as though our cosmos already sits precisely at the threshold, balanced on the edge between expansion and collapse. You can picture the universe as a glowing interior, its outermost boundary curved back upon itself, a self-contained bubble of space-time where light circles endlessly but can never escape. Inside, galaxies expand away from one another, while outside, if there even is an outside, the rest of reality continues unseen. Now imagine looking at that horizon not as a scientist but as a traveller standing at the end of perception. All around you, galaxies recede until they blur into faint red ghosts. The background light thickens its wavelengths, stretched to infinity by the accelerating expansion. Beyond that curtain, nothing. No stars, no space, no time. Just the silent boundary of what can exist for us. But perhaps that silence hides something. In general, relativity horizons are not absolute voids. They are surfaces of transformation. Information may fall in, but from another perspective, something else could be unfolding within. It's possible that the outside of our universe is not empty but full, that our horizon is someone else's beginning. You take a slow breath. Every horizon you realize is two-sided. For those within it marks the limit of vision. For those beyond it marks the birth of something new. Perhaps our cosmos is the inside of a larger structure, and just as black holes form within our galaxies, universes may form within theirs. An infinite nesting of horizons, each reflecting the next, like mirrors facing eternity. You turn your gaze back to the night sky. The light that touches your eyes has traveled nearly 14 billion years. It began before the Earth existed, before the sun ignited, before atoms found each other in the dark. And now it stops here not because it is weak, but because the universe has curved it into stillness. Somewhere perhaps a horizon beyond our own watches us the same way, curious, silent, waiting. You are standing at the edge of everything that can be known. Beyond this line lies a question too vast for light to answer, and yet it is from this edge that wonder begins. The memory of the horizon still lingers, that silent edge where light stops, where distance and time collapse into one. You're still standing there at the border of everything visible. The sky above you is not black now, it is curved. The stars appear to bend their light, falling towards some invisible center. The thought returns soft as gravity itself. If our universe truly lies inside a black hole, then where are we within it? Take a slow breath. You're about to step inside. Imagine for a moment leaving the safe flatness of space, the space you know where parallel lines stay apart, where light moves straight. Now imagine that very fabric folding, as if the universe itself were exhaling. In front of you, the geometry of existence bends inward. Every photon that tries to escape curves back like a bird caught in the wind of its own wings. We're so used to thinking of space as emptiness, a vast stage where matter performs. But space is not empty. It moves. It breathes. The presence of mass bends it like the surface of water sagging under the weight of a planet. Einstein's equations don't describe a place. They describe a relationship. You, the Earth, the Sun, the stars, each pulls on the fabric, reshaping it just by being. Now picture the inside of a black hole, not the monstrous darkness we imagine swallowing stars, but the geometry that lives within. Here, space no longer flows outward. It flows inward. Time itself tilts, sliding toward the center. Every path, every future, every ray of light leads one way down. If you could drift inside safely, you would see no wall, no fire, no edge. Only a smooth fall, endless and strangely calm. You might stretch out your hand, though out no longer exists. Even your sense of direction would dissolve. Forward becomes down, tomorrow becomes toward. You're inside the curvature, moving not through space but with it. Try to picture it with something familiar. Imagine you're standing on the surface of Earth looking across a horizon. The ground beneath you curves away so subtly you can't see it. Now multiply that curvature by 1 billion, so much that light itself cannot stay level. That's what it feels like inside the fabric of space-time near a gravitational singularity. You might ask, if everything falls inward, how can our universe be expanding? This is the paradox that defines our reality. Inside a rotating black hole, a Kerr, black hole space doesn't just collapse, it swirls. Its rotation drags the surrounding space-time with it, twisting it into a vortex. If we live within such a vortex, what we perceive as expansion could simply be the inside-out unfolding of rotation itself. Think of it like water circling a drain. From above, the current seems to rush inward. But if you could somehow dive into the swirl, you might discover another current flowing outward, a mirror flow on the other side of collapse. That is what theorists mean when they say a black hole could contain another universe. Now let's bring the scale closer to you. Gravity on Earth holds you to the ground with an acceleration of 9.8 meters per second, squared, gentle, familiar. Near a neutron star, that number multiplies by 1 billion. Near a black hole, gravity becomes so strong that a 1 millimeter difference in distance could mean a 1,000-fold change in force. And yet inside, past the horizon, you wouldn't feel crushed. You'd be falling freely, gliding through a region where space carries you effortlessly toward the center. No pain, no pressure, only the endless pull of geometry. You can almost feel it now, that silent motion under your feet, the slow curve of Earth's own gravity holding you in place. We're all already inside a field, part of a cosmic curvature we rarely notice. In a sense, we've never been outside gravity. It isn't a wall to cross, it's the shape of the universe itself. Close your eyes for a moment. Imagine the Milky Way, its stars spiraling like a silver storm. Now imagine that entire galaxy as a grain of dust floating in a space that bends around something even larger, a curvature so immense it could hold the whole visible universe. If you could step back far enough, you'd see not galaxies but light folding back upon itself, a loop where beginnings and endings meet. You're not at the edge of the black hole. You're somewhere deep within, on one of its inner layers of space-time, where light still moves, where time still flows, but all of it directed toward the same unseen center. The ancient thinkers used to say the universe was a sphere, infinite yet finite, curving back on itself. They weren't entirely wrong. What we call distance might be an illusion of curvature. What we call gravity might be the whisper of that shape. And in this moment, as you stand under the bending sky, you can feel it, that soft, invisible hand beneath everything, shaping the path of stars, cradling entire galaxies in its curve. The curve of space still holds you. You can feel it beneath every thought, every quiet breath, that gentle fall inward, as though the universe itself is exhaling through you. In the last moment, you stood inside the bending fabric of existence, watching space twist around you like a river of glass. Now it's time to ask, if space curves, what happens to time? Time does not tick the same everywhere. Einstein showed that long ago that clocks run slower near massive bodies, that gravity stretches not only space but the rhythm of existence itself. Imagine two identical clocks, one floating far from any planet, the other resting on the surface of Earth. The one on Earth ticks ever so slightly slower. The difference is tiny, mere fractions of a second across a lifetime, but measurable, real. That same effect deepens as gravity intensifies. Near a black hole, time doesn't just slow, it tilts. Picture yourself falling inward through that curved geometry you saw before. Each second you experience feels normal. Your heartbeat, your breath, the soft pulse of thought, all steady, all familiar. But to someone watching from far away, your motion would appear to freeze. You would seem suspended just above the event horizon, trapped in endless twilight, while for you the journey continues freely inside. Two versions of time, both true, both irreconcilable. This is the strange gift of gravity, it turns time into direction. Inside a black hole, time points inward, not forward, not backward, but toward. Every future moment lies closer to the center. And once you've crossed that invisible boundary, there is no path that leads away again. The arrow of time and the pull of gravity become the same. Try to imagine that feeling. You're floating inside a current you cannot see. There's no sense of falling, no wind, no motion, but you know you're being carried. It's like drifting in a deep ocean where even light has weight. Above you, the outer universe glows faintly, its light bending and reddening as it struggles to reach you. Every photon fights the curve, its color stretching from gold to crimson to black. If you could hold out your hand, the light touching your skin would not just fade, it would age. The deeper you are, the older the light appears. What was once a brief flash outside becomes an eternity inside. This is gravitational time dilation, a reality proven not just by theory but by observation. The stronger the gravity, the slower time flows, until at the center perhaps it stops altogether. And here comes the paradox that haunts every cosmologist. If time can stop, can it also begin again? Could the birth of a universe simply be the flip of that flow, a reversal, a rebound, the moment when an inward collapse becomes an outward expansion? Theorists have wondered if the Big Bang itself was the other side of such a moment. From one perspective, a black hole consumes. From another, within that singularity, new space-time unfurls, flowing outward instead of in. In that sense, the flow of time might be relative not only to place, but to which side of reality you stand on. You might imagine it like water circling a drain. From above, you see the spiral rushing inward, matter collapsing, light vanishing. But from beneath, if such a view existed, you would see a fountain erupting outward, new currents, forming a new world, expanding into being. Now think about light itself, not as something that merely illuminates space, but as the messenger that defines it. Every second, beams of light curve, stretch, and age as they travel through the warped geometry we call gravity. The light that leaves a distant star may take billions of years to reach us, and yet in its own time that journey happens in an instant. For the photon, no time passes at all. It leaves and arrives simultaneously, an eternal now stretched across eternity. So whose time is real, yours or the photon's the universe doesn't choose? It allows both, weaving them together into a single tapestry where flow and stillness coexist. You take a breath, and the question deepens. If time can bend, if light can stretch, then what is real motion? Are we moving through time, or is time flowing through us? Outside, galaxies drift apart, space expands, but from the inside, perhaps it's all one great rotation, a swirl of reality where direction is just perspective. For what we call the future may simply be the way gravity points. Close your eyes. You are floating between two infinities, the collapse that created you and the expansion that carries you. Light moves past you, slow as thought, and time feels soft under your fingers. It isn't a river you walk through, it's the ocean that holds you up. You've been falling for a long time now, not falling like a stone, but falling the way light does, softly, endlessly drawn by the geometry of something greater. Every breath you take feels longer, every sound stretches thinner until silence itself seems to hum. This is not motion anymore, it is arrival. You have reached the still point, the quiet heart inside the curve, where the pull of gravity and the flow of time meet and cancel each other out. Outside, time still rushes onward. Galaxies spin, stars burn, life begins and ends. But here all that movement folds into one continuous moment. Neither past nor future, only the pure presence of being. Physicists call this the singularity, a place where the equations that describe the universe turn upon themselves and vanish. Mass becomes infinite, space becomes curved beyond measure, and time loses meaning. It's not that time ends here, it simply no longer passes. Every moment that ever was, every moment that will be, exists simultaneously. You're standing or floating inside a moment stretched to infinity. Try to imagine it. You reach out your hand, but there is no out. There is no before or after. Even the idea of direction dissolves. It's like standing in the center of a whirlpool where the water has gone perfectly still. The surface looks calm, but beneath it, the entire ocean waits coiled with endless potential. Now, think of the universe itself. Everything that has ever happened, from the birth of atoms to the rise of stars, might be recorded here in a pattern too deep to read. The singularity is not a place of chaos, but of total memory. A mirror so perfect that every reflection exists at once. If you could hear anything here, it would not be noise, but resonance, the low vibration of existence itself. Some say this hum might be the same tone that echoed from the Big Bang, the frequency of creation still reverberating in the dark. Perhaps this is where universes dream each other into being, each heartbeat of a black hole, a pulse that gives rise to another cosmos. Close your eyes, the stillness deepens, space folds in, and for the briefest instant you sense everything, the stars, the galaxies, the people who once looked up and wondered. All of it is here, suspended in this timeless glow. If this is the end of falling, then it is also the beginning of something else, a boundary that is not a wall but a door. Perhaps this still point is not death, but balance, the perfect harmony, where creation and collapse are one. You are not moving now, you are being moved by the shape of existence itself. And as the universe holds you perfectly still, you realize time has not stopped. It has simply become part of you. The stillness lingers. You can still feel it, the quiet place where time stopped, the heart of the black hole where motion turned to meaning. For a moment it seemed like the end of everything. But endings have a strange habit in this universe. They loop back on themselves. The deeper you go, the more every ending begins to look like a door. You're still there, floating in the slow breath of the singularity. The dark folds ripple once like a sigh, and then you feel it pressure. Not the crush of gravity this time, but a kind of resistance, as if the universe itself refuses to stay silent. Something pushes back. Something begins to grow. In the equations, physicists call it quantum pressure, the smallest tremor of energy resisting absolute collapse. In their simulations, this resistance can cause a dying universe to rebound, to unfold itself into expansion again. Not a single big bang, but many, each one following the death of the last. Imagine that. No first dawn, no singular origin, only rhythm. The cosmos breathing in, breathing out. Every collapse seeding the next creation. Every black hole perhaps a womb of new reality. If you could stand outside time, if such a place existed, you might see the pattern stretched like a pulse across eternity. Universes rising and falling like waves. From one another is born, from that another still, each carrying echoes of the one before it, the same constants whispered forward, slightly altered like DNA mutating with each generation. It changes how you see everything. The Big Bang is no longer the first heartbeat. It's one in an infinite sequence of heartbeats. The singularity is not death, but compression, the inhale before the exhale. And in that moment between breaths, the universe rewrites itself. Scientists call this vision the Big Bounce. According to this model, our universe did not begin from nothing but from the collapse of a previous cosmos. When that universe reached its densest point, gravity no longer pulled, it pushed. Space rebounded, flinging new matter outward, forging stars, galaxies, and finally us. It's hard to picture such a scale. But imagine the way a rubber ball flattens when it hits the ground. For an instant, all its motion is stored in the smallest space possible. Then, with perfect symmetry, it springs back, carrying the memory of the impact into its next leap. That is what the Big Bounce would feel like on a cosmic level, an entire universe folding and unfolding, an endless heartbeat of creation. So maybe there was no single beginning. Maybe there was never a true first moment. What we call the start is simply the point where memory fades. We are the children of a rebound, the bright echo of a universe that once collapsed into itself, that chose somehow to rise again. And in this endless cycle, black holes take on a new role. They are not just devourers, they are bridges. Each one could be the seed of another cosmos, its own space, its own time, its own rhythm. When you stare into one, you might not be looking into destruction, but into the future birth of another sky. The silence you felt before wasn't the end of everything. It was the pause between cycles, the breath before the universe began to sing again. The pause between breaths is over. You can feel it, the stillness from before beginning to stir. The singularity that once held its silence now quivers, as if something on the other side has begun to exhale. What was once a point of no return is now a seed swelling with the weight of everything that once was. You remember the last thought from before, there was no true beginning, only cycles. If that is true, then every black hole, every singularity scattered across the sky might be the doorway to another round of creation. Perhaps the universe never stops making itself. Perhaps it's not a straight line, but a forest of branching realities, each born from the collapse of another. Astronomers once thought of black holes as endings, a final place where matter vanished, where light and time were torn away from meaning. But in the last decades, a quiet revolution has begun in physics. Equations that once described destruction now whisper of renewal. The curvature of space inside a black hole might not collapse into nothing, but instead bounce expanding outward into a separate hidden space-time. Imagine standing at the event horizon, the boundary of no return. From the outside, you see only darkness. No light escapes. To an external observer, anything that falls in slows, forever frozen in time. But from inside, the view is different. You're not falling toward an end, you're falling toward a beginning. Time itself flips its direction, and what looks like collapse from one side feels like expansion from the other. It's a strange symmetry. Every black hole could be a mirror reflecting collapse on one side as creation on the other. Physicists call this the white hole hypothesis, the idea that what goes in through one face of the singularity may come out through another in a burst of new space-time. In that sense, the Big Bang could be the interior of a black hole belonging to some larger parent universe. Try to picture it. Somewhere beyond our cosmic horizon in another layer of reality, a massive star collapsed billions of years ago. Its core folded in its light swallowed, and inside that impossible darkness, a new bubble of space-time bloomed our universe. Its expansion was our Big Bang, its matter our galaxies, its radiation our light. To you standing here in imagination, that means our entire reality could exist within the belly of another. We are not outside anything. We are inside something, a pocket of space-time nested within a greater cosmos. A child universe suspended in the womb of a parent one. Theorists like Lee Smolin call this cosmological natural selection, the idea that universes reproduce through black holes. Each one inherits slightly different constants. A tweak in gravity here, a shift in the speed of light there, and the ones most capable of creating stars and black holes become the most prolific at birthing new universes. It's evolution written not in DNA but in geometry. So when a black hole forms in our universe, perhaps it isn't an end but an act of cosmic reproduction. Each collapse adds to the branching lineage of existence, the universe ensuring its own continuity, one singularity at a time. Think of it like a tree made of time. Each trunk is a universe, each branch a black hole growing into a new cosmos. The roots vanish into darkness, but the canopy stretches forever, a multiverse that keeps flowering one bloom at a time. You lift your gaze again, and the night sky feels different now. Every point of darkness, every black hole you cannot see is not an abyss, but a potential cradle. A place where the next universe is already forming quietly and visibly within its own horizon. The thought is dizzying. It bends your sense of finality, of death, of meaning itself. But it also feels right. The universe, like life, never stops becoming. It falls, it folds, it begins again. And if that's true, then maybe even now, inside the heart of some distant star, another sky is already being born. The idea lingers like a pulse, quiet, persistent, alive. You can still feel it from before, that slow heartbeat of creation, black holes blooming into new universes, each one carrying the imprint of the last. If the cosmos truly renews itself in endless loops, then a question rises from the silence. What if anything survives the turn of the cycle? You drift again through that imagined forest of universes, each one expanding outward, each one born from the ashes of the one before it. From the outside they are bubbles of space-time, from the inside they are skies, stars, and memories. But if everything resets, why do some patterns feel familiar? Why does the universe seem to echo itself? Some cosmologists suspect that traces of a previous cosmos might still be written into ours. In the faint patterns of the cosmic microwave background, they search for circular imprints, subtle scars in the oldest light of all, as though two universes once touched at the moment of rebirth. Roger Penrose called this vision conformal cyclic cosmology. Each universe passes its final breath to the next, leaving behind a faint whisper of energy, a kind of cosmic memory transferred across time. Imagine if those faint ripples, those nearly invisible rings of radiation in the sky, were the fingerprints of another age, a universe older than ours whose stars died billions of eons before our own Big Bang. Its light now stretched into near silence, but still faintly pulsing in the background of everything we see. It's a humbling thought that our entire existence could be built upon the remains of a previous cosmos, that the particles in your body, the atoms in your bones, might carry the encoded memory of another universe's collapse. Not metaphorical memory, but literal, the pattern of energy, the symmetry of laws, the constants that define how matter behaves. Those didn't come from nowhere. They were passed on. Perhaps that's why the universe feels so strangely fine-tuned. Why the forces seem balanced precisely enough to allow stars, planets, and life to exist. Because they are not random, they are inherited, like the rhythm of a heartbeat that continues even after the heart itself has changed. So when we ask, where did we come from, we might be asking a smaller question than we think. We are not just the result of one explosion, but the continuation of many an unbroken sequence of cosmic resurrections. Our universe remembers, and in some subtle way, so do we. Maybe that's why we look up at the stars with such longing. Some part of us recognizes their light, not from this life, but from before, from a sky that burned and faded long ago. If the universe keeps cycling, if the next cosmos already waits inside some distant singularity, then we, everything we are not a coincidence. We are the reflection of a pattern that refuses to die. A thought carried forward through the dark. a memory whispered from one universe to the next, and one day when this cycle ends, when our stars burn out and the last atoms dissolve, that memory will continue again, carved into the structure of a newborn cosmos, encoded in its first light. The universe will wake, and somewhere in that bright beginning another being will look up and wonder, just as you do now, have we been here before? The thought from before still hums inside you that every universe may be born from the ashes of another, each one a breath in the endless lungs of existence. But if that's true, then something must give birth to the next breath. Something colossal, something that can hold the weight of an entire cosmos. You open your eyes again. The darkness before you isn't empty anymore, it moves. Out of the still black, a structure begins to emerge, a curve, a shimmer, a vast gravitational shadow. It isn't a star. It isn't even a galaxy. It is the thing that galaxies orbit around. We call them black holes, and among them there may exist creatures so immense that language itself starts to fail. They are called stupendously large black holes, or slabs for short, and they could be the most massive objects in existence. Imagine for a moment that you're standing at the edge of one, not near the event horizon of a small stellar black hole, not even near the monstrous ones in galactic centers, but near a thing that bends space across millions of light years. You look up, and the sky curves. Galaxies drift like grains of dust caught in its pull. If our entire Milky Way fell toward it, it would vanish like a snowflake tossed into a storm. A typical supermassive black hole like Sagittarius A at the heart of our galaxy weighs about 4 million suns. A slab could be 10 billion times larger. Its event horizon might stretch across hundreds of thousands of light years wider than the space between us and the Andromeda Galaxy. To give it form in your mind, if our sun were a single cell, then this black hole would be a living planet. Its gravity so vast that even light must bow as it passes. Scientists haven't seen a slab yet, but equations allow them. The math of relativity places no upper limit on mass. If enough matter collapses slowly enough, it can grow without end, feeding on galaxies, clusters and voids. Some theories suggest that the centers of massive cosmic filaments, the highways of galaxies threading through the universe, could hide these behemoths. Black holes so large that we mistake their influence for the shape of space-time itself. You try to imagine how something like that forms. Maybe in the early universe, when matter was packed thick as fog, gravity could sculpt a black hole before galaxies even took shape. A single region collapsing first, consuming everything nearby, a seed that grew faster than the cosmos could stretch away. Over billions of years, it would have swallowed everything within reach: stars, planets, even other black holes, until nothing remained but its invisible heart. If you could fall into one, the journey would not be violent, at least not at first. For something that large, its tidal forces at the horizon would feel gentle. You might not even notice the moment you crossed it. Only later, deep within, would the geometry of space begin to twist, time begin to flow in strange directions, and your perception of reality start to blur. Pause for a moment. Picture that a black hole so vast that it feels infinite, so patient, that it consumes galaxies like a tide washing over continents. You stand there, and the scale overwhelms you, every human thought suddenly small, every question collapsing into awe. If one of these slabs exists, it could contain millions of galaxies, entire clusters folded into its event horizon. Some scientists even propose that its interior might be large enough to resemble our own universe, that what we call cosmic expansion could actually be the unfolding of space inside a larger black hole. And if that's the case, if slabs truly exist, then perhaps our universe is one of them. You look back on what you've learned. We thought of black holes as devourers, but maybe they're architects. Maybe their hunger isn't destruction, it's transformation. Each one could be a seed of space-time, a bridge from one reality to another. Now take a breath. Look up. The night sky, the map of galaxies you think you know, might only be a fragment of something vaster. Each bright cluster, each faint spiral, a bubble caught in the pull of some greater void. And beyond even that, there may be one final horizon, a dark ocean so large that our entire observable universe is just a ripple on its surface. If you could step back far enough to see it, to see everything at once, you'd find that the universe is not scattered and random, but curved inward, held together by invisible giants sleeping in the dark. They are the anchors of existence, the silent centers of everything that moves. So what happens if one of those giants lies beyond our cosmic boundary? If our universe itself is a flicker inside a stupendously large black hole? It sounds impossible, and yet perhaps that's what impossibility looks like when it's real. The question from before refuses to fade. It hangs there suspended in the silence that follows awe if black holes can grow larger than galaxies. If a stupendously large black hole can curve space across millions of light years, then what if one of them already holds us not outside but within? The idea sounds impossible, and yet the more you turn it over, the more it begins to feel inevitable. Because if the universe has no beginning-only cycles, and if every black hole could give birth to another universe inside it, then there must be a parent, a greater host, a cosmic womb vast enough to contain everything we can see. Imagine that our entire observable universe, the stars, the galaxies, the microwave background, the flicker of ancient light, all of it could exist within the event horizon of a single black hole belonging to another universe. From that outer perspective, our cosmos is not infinite. It's a region of curved space-time, a bubble expanding within a larger geometry. You're not looking out into open space. You're looking across a surface of curvature, the inner lining of an unimaginable being. You breathe in, trying to picture scale. If Sagittarius AS, the black hole at our galaxy's center, is the size of a pinhole in this analogy, then a slab capable of containing the observable universe would stretch beyond comprehension, billions of light years across, with a mass comparable to the sum of all galaxies combined. A single horizon vast enough to hide creation itself. This is the black hole cosmology hypothesis. The proposal that our Big Bang was not an explosion into empty space, but an emergence from the other side of a gravitational collapse in some greater universe beyond our reach. The singularity that began us might be the interior of a black hole elsewhere. To the beings of that parent cosmos, it was a catastrophe, a star collapsing. To us, it was dawn. Physicists like Nikodem Popławski and Lee Smolin have modeled this idea, suggesting that each black hole could tunnel through the singularity, forming a new expanding region of space-time on the inside. What we call the beginning might be the echo of matter reborn through a cosmic bridge. The equation works both ways, collapse on one side, creation on the other. So what would that mean for us? It means that the boundary we call the edge of the observable universe might not be the limit of existence, but the inner wall of a horizon. The reason we cannot see beyond it is not because light hasn't reached us, but because that light cannot escape. It isn't distance that blinds us, it's geometry. You close your eyes and imagine standing at the edge of that horizon. If you could look outward beyond the cosmic microwave background, you would see not emptiness, but the interior curve of the black hole's event horizon itself. The same structure that hides stars in our universe could be hiding us in someone else's. It's a thought both beautiful and terrifying. Because if our universe lies within a slab, then everything time-light, even the laws of physics, belongs to the environment of that larger structure. We are the offspring of another cosmos, children of a collapse too vast to witness. Perhaps the symmetry of nature demands it. Stars die and become black holes. Black holes die and become universes. Universes collapse and become stars again. A recursion of creation, each layer giving birth to the next. And if that's true, if we exist inside a slab belonging to a universe beyond our reach, then what lies beyond that? Could there be a hierarchy, an infinite tower of realities, each one nesting inside another like mirrors, facing into eternity? You lift your gaze again, and suddenly the night sky feels intimate, not a distant canvas of unreachable light, but the curved interior of something alive. Each galaxy, each beam of starlight is a molecule in a larger organism of space and time. The heartbeat of the parent universe may still echo in our own, in the slow drift of galaxies, in the background hum of ancient radiation. So could a slab truly hold us? Could our reality be the inner breath of something else science does not yet know? No telescope can look beyond the horizon. No signal can escape to tell us what lies outside. And yet every black hole we find reminds us that boundaries may not be barriers, they may be bridges. The thought from before still trembles in your mind that we might be living inside a black hole so vast that even our galaxies are only dust in its curve. If every beginning hides within an ending, then perhaps the same symmetry holds true for the end of our own cosmos. If a universe can be born from collapse, then one day it must also collapse again. You feel it in the air between stars, the slow drag of gravity that never truly went away. It's faint now, masked by the accelerating pull of dark energy, but some physicists still whisper that one day the expansion of the universe could falter, the outward breath could stop, and then everything would begin to fall back. Imagine that moment. Galaxies that once drifted apart for billions of years pause, hesitate and start to move inward. Distances shrink. The deep black of space begins to thicken with returning light. Clusters collide, their halos merging like waves folding over themselves. Everywhere, motion reverses the great unwinding of creation. If you could stand somewhere safe enough to watch it, you would see the sky begin to close. The constellations stretch, distort, then vanish as gravity pulls all light homeward. Every star that ever was begins to sink back into the same gravity well. Every particle, every photon tracing the long road back to the origin that once expelled them. Physicists call this fate the Big Crunch, a universe that grows tired of its own expansion and finally succumbs to the weight of itself. At first, the collapse would be slow. Galaxies would drift closer over billions of years, their motions imperceptible to any living eye. But as space contracts, the process accelerates. Temperatures rise. Cosmic background radiation shifts back toward blinding light. Stars reignite not from birth, but from pressure. The very fabric of space-time begins to wrinkle, folding inward, carrying everything that ever was back to a single, impossible point. It is the reverse of the Big Bang, a cosmic inhale drawn too deep, entropy running backward, light squeezed into heat into matter, matter into pure energy until even energy forgets what it means to move. Now close your eyes. Try to feel what it would be like. Every atom in your body, every breath of air, every thought, all being pulled toward the same destination. No violence, just inevitability. The universe itself curling inward, seeking balance. Some theories suggest that at the final moment when density becomes infinite and time collapses into itself, the singularity does not mark death but renewal. The energy trapped in that point could rebound again, bursting outward into another expansion, another universe, another beginning. It would mean that the end and the beginning are not opposite things at all, just two faces of the same rhythm. But others think differently. They say that gravity will not let go this time, that collapse is collapse, and when the final moment comes, everything will fold so tightly that not even time can unfold it again. A frozen point in the dark, a silent monument to existence itself. You look out once more. The stars above you shimmer faintly, their light already ancient, already travelling toward the end that awaits all things. And in that quiet realization, you sense something almost comforting, that the universe is not being erased but returning home. The Big Crunch is not destruction, it is reunion. Every photon, every life, every echo of thought coming back together at last, folded into one final blinding instant of being. The vision of collapse still echoes in your mind, the universe folding in on itself, light returning to its source. But what if the opposite happens? What if gravity never regains its grip, and the cosmic breath that began with the Big Bang never draws back in? What if the expansion doesn't stop but continues endlessly until all warmth, all motion, all memory of life simply fades? You breathe out into the dark, and the silence answers. The stars above are still burning, but you can already imagine their future, each one consuming its fuel, each one destined to go dark. This is the other fate that physicists whisper about, the big freeze, the slow, inevitable cooling of everything that exists. It begins gently. Galaxies drift farther apart. The light between them stretches its wavelengths, pulled thin by the expansion of space. What once was golden becomes red. What was red turns to black. The night grows deeper, and one by one the galaxies slip beyond each other's sight so far apart that no photon will ever cross the distance again. Imagine the Milky Way millions of years from now sailing through a void so vast that even the nearest galaxy has become a ghost, its light stretched beyond detection. The sky would be empty, no constellations, no neighbouring suns, only the cold shimmer of dying stars. At first, stars like our sun burn out quietly, swelling into red giants, before collapsing into white dwarfs, the dim glowing embers of stellar fire. They will linger for trillions of years, their light fading ever slower, until even that faint glow goes out. Black dwarfs, dead stars will fill the dark, each one colder than the space around it. And still the expansion continues. Gravity weakens, galaxies unravel as their stars drift apart. Even the great black holes, the last powerful engines of the cosmos, will begin to evaporate through Hawking radiation. Over inconceivable spans of time, they will fade spark by spark until not even darkness remembers them. Try to picture that far future. There will be no galaxies, no stars, no planets, only scattered particles adrift in an ocean of nearly perfect emptiness. the temperature of the universe will approach absolute zero just a fraction of a degree above nothing. Molecules will cease to move, atoms themselves may decay, space will no longer glow, time will no longer mean anything. It's not a dramatic ending. There is no explosion, no collapse, no final blaze. The Big Freeze is a whisper, a universe quietly forgetting how to exist. Entropy wins not through violence, but through patience. You stand there imagining it. The last star flickers then fades. No observer remains to see it. No sound, no breath, only the soft, endless expansion of space, the universe stretching itself so thin that it can no longer remember what warmth felt like. And yet, even in that frozen silence, a strange peace lingers. There is a symmetry in this ending, the universe returning to the same stillness it emerged from. Perhaps this is what eternity feels like. Not fire, not chaos, but rest. You think of the heat in your own body, the spark behind your eyes, and realize that all of it, every photon of warmth, is borrowed from the universe's long-ago fire. We are the temporary memory of light carried forward until the last ember fades. When that time comes, when the cosmos cools to a final quiet equilibrium, there will be no one left to say that it has ended. Because endings require witnesses and the Big Freeze leaves none. The cold from before still lingers in your thoughts, the universe fading, slowing, falling asleep. But what if the opposite awaits us? What if the universe does not drift into silence, but screams apart? For every whisper of stillness, there is an echo of violence, and this one is called the Big Rip. It begins not with collapse or cold, but with acceleration. The galaxies are already fleeing from one another, their speeds rising faster than gravity can pull them back. This invisible force we call dark energy makes up nearly 70% of the cosmos, a pressure that pushes rather than pulls stretching space itself. At first, it seems gentle, a slow drift between galaxies. But if dark energy grows stronger with time, its push will outpace the bonds that hold everything together. What starts as expansion could turn to disintegration. Imagine looking up at the night sky 1 billion years from now. Galaxies would already be receding faster than light, their glow pulled thin until it disappears. The sky empties, leaving only the faint shimmer of your own galaxy floating alone in infinite dark. Then the tearing begins. The Milky Way itself starts to unravel, the pull between its stars overcome by expansion. Solar systems drift apart, planets fall away from their suns, even the gentle orbit of Earth is undone, the horizon stretching beneath your feet. You would not see it happen, space itself would move, not the objects within it. Reality would slide outward like a sheet being torn from the center. As the rip intensifies, the scale of destruction tightens. Stars are torn from their orbits, planets shredded into dust molecules stretched until their bonds break. The force doesn't pull at separates. Between every particle, every atom, the space itself expands, faster than light can cross it. Nothing can hold together. Not matter, not gravity, not even time. Close your eyes for a moment. Picture the last instant of such a universe. The galaxies long gone, the stars disintegrated, the atoms themselves stretched into a fog of quarks. And then, in the final fraction of a second, even those particles lose cohesion. Space tears faster than they can respond. The universe doesn't collapse, it ruptures. Scientists describe this as a singularity of expansion, the mirror image of the Big Crunch. Instead of matter crushed into infinite density, space expands into infinite emptiness. Both ends meet in extremity, the universe too full or too empty to continue. It's hard to imagine such violence. There is no explosion to see, no shockwave, no sound. Everything simply loses its grip. The laws that once bound the cosmos become meaningless. Even light has nowhere to go, there is nowhere left. And yet somewhere inside that chaos there is still symmetry. Because every expansion contains its own collapse. Every fracture hints at a rejoining. If the universe can tear itself apart, perhaps those fragments could seed the birth of new realities, small disconnected bubbles of space-time, each carrying the ghost of what came before. You stand at the imagined edge of this event, your mind trying to hold the shape of something that can no longer be held. Every atom in you stretches, every thought elongates into the infinite. The fabric of being is slipping through itself, and for a moment you glimpse what it means to unmake. Perhaps this too is a kind of creation not from order, but from release. A cosmic exhale so powerful that it becomes the breath of another form. Then silence again. No sound, no space, only the echo of expansion reverberating through what remains of time. The Big Rip is over. and somewhere in the wake of what was torn apart, the first vibrations of a new universe begin to stir. The tearing still echoes in your mind space, unraveling matter, dissolving the universe, expanding faster than it can exist. You imagine the last threads of time snapping apart. But what if the end does not come through expansion or collapse? What if it begins in silence, not with destruction, but with an update? Physicists call it vacuum decay, and its name sounds deceptively harmless. It's not an explosion, not a cosmic crash, but a quiet, unstoppable transition, the universe changing its very definition of real. To understand it, you must return to the idea of energy. Even in the deepest void space is not truly empty. Quantum fields ripple there, restless and unpredictable. They form the foundation of everything. Matter forces light itself. But what if the vacuum we call stable isn't the lowest possible energy state? What if there exists another deeper level of reality? A true vacuum and our entire universe is floating in a false one. Imagine a landscape of hills and valleys. Our universe rests in a shallow dip, a valley that feels stable, but beyond its ridge lies a deeper one. If one day a particle somewhere crosses that ridge by chance, or by violence, it could trigger the shift. A single point, a quantum spark where the false vacuum gives way to the true. From that spark, a bubble of true vacuum would begin to expand. Not at the speed of sound, not at the speed of light, but faster. Nothing could outrun it. No warning, no defense. Wherever it touches, the laws of physics rewrite themselves instantly. Atoms collapse, forces alter time itself, loses continuity. To observers, it would be over before they even knew. The universe would not explode, it would update. A new reality replacing the old. And because the new vacuum is more stable, it would spread endlessly, consuming everything, galaxies, stars, even black holes, until the old universe ceases to exist. You try to imagine it. No sound, no flash, just a perfect stillness sweeping across the cosmos, the fabric of being rolling over into a new configuration. Perhaps it would create a new kind of matter, new constants, new ways for energy to move. Or perhaps it would be utterly uninhabitable, a place where even atoms cannot form. It's a terrifying concept because it could already have begun. Somewhere far beyond our horizon, a bubble of true vacuum could be expanding right now, and we would never know until in an instant everything simply changed. But the deeper question is not scientific, it's existential. If this happens, does it mean the end of the universe, or merely the next step of its evolution? Perhaps as the old vacuum collapses, a new structure takes shape, one more stable, one more complete. In that sense, the big slurp isn't destruction, it's transformation. You close your eyes and picture the universe as a living field shedding its old skin for a new one. Each rebirth, each transition, an echo of the cycles you've already seen. The universe doesn't end, it corrects itself, seeking balance in the deepest possible form. And as the thought settles, you realize something quiet, almost peaceful. Whether through collapse, freeze, rip, or decay, each ending still carries creation within it. Each silence holds a pulse. Each darkness hides a new dawn. Perhaps one day, somewhere within that true vacuum, a new cosmos will bloom. Different laws, different light, but still a reflection of this one. And maybe in that newborn sky, some new consciousness will rise, look upward into the dark and whisper the same question that began it all. What if the universe we live in was never really the first? The silence from before still hums that moment when the false vacuum collapsed, when one universe ended not with fire but with an unseen shift. Yet even in that quiet undoing, something new began to stir. The collapse of one reality may be nothing more than the breath that inflates another. Imagine it now. The last wave of the old universe has faded, and in the stillness of that aftermath, tiny quantum ripples start to rise. Each ripple swells, folds the vacuum upon itself, and somewhere, perhaps everywhere, a new bubble begins to grow. A new law, a new constant, a new sky. This is the vision of eternal inflation, a theory that says our universe is not alone. Inflation never truly stopped after the Big Bang. It simply kept unfolding elsewhere, birthing countless regions of space-time, each isolated from the others by the speed of their own expansion. Our cosmos is just one bubble in an infinite foam, a single droplet among an ocean of light. Close your eyes. Try to picture it. A cosmic field stretching beyond any boundary, a storm of creation where every second new universes ignite like sparks on dark water. Each spark grows into a world, a reality sealed off by its own horizon. They never meet, never collide, and yet they all exist together. Now imagine standing in that ocean, you suspended between bubbles watching as each one shimmers with its own laws of physics. In one, gravity might be weaker stars never form only clouds of cold hydrogen. In another, atoms hold tighter and light itself curves too soon, collapsing before galaxies can bloom. And then there's ours, balanced just enough for life to notice. Can you feel it? The fragile coincidence that lets you breathe, that allows your atoms to hold hands, that lets you gaze up and see the memory of beginnings. It is the luck of a bubble that inflated just right. But somewhere right now, another universe is doing the same, expanding, cooling, evolving, unaware that we exist just as we are unaware of it. Scientists call this landscape the multiverse, but poets might call it a hall of mirrors. Each mirror shows a world both familiar and strange, a reflection tilted by different laws, different histories, different forms of you. If reality can branch, then every possibility has already happened somewhere. The star that collapsed here might have survived there. The choice you never made might still be unfolding in another stretch of space-time. So when you dream, and you feel as though you've lived another life walking through a city you've never seen under a sky, you can't recall, maybe it's not imagination at all. Maybe your mind is brushing the edge of a neighboring bubble, and yet even among infinities our universe remains something intimate, a small pocket of order within a vast chaotic sea. Its constants, its dimensions, the slow rhythm of its aging light, all attuned to a symmetry so precise that it almost feels deliberate. Perhaps among the infinite reflections, ours is the one that became self-aware enough to ask why. Perhaps consciousness itself is what the universe uses to look back at its own creation. You breathe again. The silence of space surrounds you, but it no longer feels empty. Every direction, every atom, every quantum fluctuation could be a doorway to somewhere else. And as you float there, you begin to wonder if every possibility exists. Then what does it mean to be here? To be in this branch, in this bubble, in this breath of reality? The thought from before lingers like a reflection that won't fade. You remember the ocean of bubbles, each one a universe, each one alone. But what if those worlds are not so distant? What if their surfaces, their boundaries sometimes tremble and overlap? You take a breath. The air feels thinner, as though reality itself has shifted slightly beneath your feet. If the multiverse is real, then every possible version of you exists somewhere, each born from a different decision, a different path, each living out a story the others never chose. Not fantasy, just the mathematics of quantum branching. In physics, it's called the many worlds interpretation, first whispered by Hugh Everett in 1957. He imagined a world where every quantum event, every split between yes and no, between life and death, creates a new timeline, a new reality. No collapse of the wave, function-only division. Every outcome exists. Every possibility breathes. You're standing now in front of an infinite corridor of mirrors. Each one reflects you, but with subtle differences. One smiles when you do not. Another looks away. And deeper still, the reflections multiply, not endlessly identical, but endlessly unique. You can't tell which one is the original. Perhaps there never was one. Hey Tong Tong, you wake up one morning and a faint memory haunts you. A street you've never walked, a voice you've never heard, a life that feels like yours but isn't. Science might call it déjà vu, but in a multiverse it might be something else. A resonance, an echo from another version of you who took a different road, who made the opposite choice. There's a quiet strangeness to that idea, a beauty too, that we're not just single stories but an orchestra of possibilities playing at once. Every heartbeat you feel might be mirrored elsewhere, slightly slower, slightly faster, in a world with stars just a little colder. Even our universe could be one of these reflections, a version shaped by a tiny difference at its birth. One altered particle, one quantum tremor, and the entire history of time would unfold differently. Perhaps in one branch, the Milky Way never formed. In another, life began in oceans made of methane. And in one, this one consciousness rose and dared to look at the stars and ask why. But if there are infinite versions of you, which one is the real you? The question unravels itself as soon as it's asked. Reality might not care which copy you are. Perhaps identity itself is not fixed. It's a pattern repeated across time, a melody replayed in infinite keys. And here's the strange comfort. If each you exists, then none of you are truly lost. Every love, every failure, every word unspoken is still being lived somewhere in some quiet branch of the multiverse. You lift your eyes, and for a heartbeat you imagine the universe is folding inward like mirrors reflecting mirrors, until all images converge into one infinite light. It's as if the cosmos is watching itself through your gaze, curious, wondering what it has become. In that reflection you sense the next question forming. If every universe mirrors another, is there a final mirror? A last horizon that reflects everything, every life, every cycle, every echo back to its source. Perhaps that's where all reflections meet. Perhaps that's where the universe finally recognizes itself. And as this thought unfolds, you feel the pull of that final vision, a light not just seen but remembered, drawing you toward the last and quietest question. What happens when the mirror looks back? The reflections from before still shimmer in your mind, endless selves, endless worlds, each a fragment of the same cosmic thought. You can almost feel the hum of them, a quiet chorus vibrating through the dark. But every mirror, no matter how infinite, must have an edge. Every reflection must one day face the original light. So we come to the question that lies at the end of all mirrors. If every universe reflects another, then what reflects them all? You look up. The night sky itself is a mirror not of glass but of time. The light you see from each star is ancient, some of it older than Earth, some of it nearly as old as the universe itself. When you gaze at the faint shimmer of the cosmic microwave background, you're seeing the oldest light of all, the afterglow of creation, a soft radiation stretched thin by billions of years of expansion. It is the universe's own childhood photograph, a fossilized memory of the moment it learned to shine. And in that light, faint as a whisper, there may still be traces of the worlds that came before, circular imprints, tiny asymmetries, ripples left behind by collisions or births beyond our comprehension. Physicists read them like hieroglyphs, searching for meaning in the glow, for signs that time has looped, that another universe once touched ours at the instant of its birth. You let your eyes close and imagine it, the universe looking into itself, its past and future intertwined. Maybe this final mirror isn't a boundary at all, but a conversation, a reflection so complete that it erases the distance between what is and what was. If so, then every photon, every atom, every pulse of thought in your mind is part of that reflection. You're not outside the mirror, you are part of what it reflects. The eyes through which you see the universe are the same eyes through which it sees itself. It's a strange comfort, isn't it? To think that consciousness might simply be the light of the cosmos folded inward, a self-recognition written in biology and starlight. When you wonder about the universe in some profound way is wondering about you. Perhaps that's what all of this has been leading to, not a discovery, not an ending, but a realization that we were never separate from it at all. Every cycle of collapse and rebirth, every black hole and every spark, every silence between stars, it's all part of the same reflection. A single light learning to see itself in endless forms. And when the final mirror closes, when time itself curls back to where it began, that light won't vanish. It will return not as memory, but as potential waiting to be reborn. You breathe once more. The stars shimmer above like ancient eyes, and for the first time you realize they've been watching you too. The echoes fade now. The reflections, the cycles, the vast mirrors of existence, they dissolve into the same silence that began everything. You can almost feel the universe exhale a long, soft breath after an age of becoming. Look up one last time. The night above you is not empty. It is the inside of something enormous, a curved horizon that bends around us like a womb of gravity. If the theories are true, if our universe really lies within a black hole, then every star, every galaxy, every breath you take exists on the inside of an event horizon. We are living within a memory of collapse, floating inside a shadow that became light. It changes everything, doesn't it? The Big Bang would not be an explosion outward, but the inner birth of space itself, a bloom inside the darkness of another world. The outer universe, our parent cosmos, may still exist beyond that horizon, its own stars circling its own watchers, wondering if something was born within one of their dying suns. And we, the spark that flared within that death, became a universe that thinks, dreams, questions. Perhaps every black hole is the seed of a new cosmos. Perhaps creation is not a single act, but an infinite heartbeat collapse, and rebirth, darkness, and light, each feeding the next. And if that's true, then we're not trapped here. We are part of a continuum, a bridge between the seen and the unseen. Imagine it when you look at the center of the Milky Way at Sagittarius A, that quiet, hungry mouth of gravity. You might be staring at the beginning of another universe just starting to breathe. Somewhere within that darkness, another sky may already be forming its own stars, igniting its own beings, looking upward, whispering the same question we do tonight. Where did we come from? The universe is not ending. It is only changing form like a thought, folding into dream like a wave returning to the sea. Light does not vanish when it falls into darkness. It becomes part of something larger, something beyond the limits of what it once was. So if we truly live inside a black hole, then perhaps we are closer to infinity than we think. We are living inside the echo of creation, where time stretches, where space curves, where the laws of physics become poetry. And one day, when this universe finally reaches its stillness, when even the last particle has given up its energy, maybe that quiet will become the seed of another light. Another dawn, another question. For now, the stars dim and the universe closes its eyes. Its expansion slows in your heartbeat, its gravity hums behind your breath. You can rest too, because in the end, we are not outside the cosmos, we are inside its dreaming. Sleep well, for as you drift into darkness, so does the universe, and perhaps in your dream it will begin again.